Okay, so in this video we are going to learn how to find the volume of solids that is revolved around the x-axis and the y-axis using a method called the disk method. So an important part of the disk method is using the equation of the circle, and you might have learned this before throughout your past years. The area of a circle is pi r squared, and we are going to use this equation for the disk method. So first, let's see an example. Find the volume between x equals 0 to x equals 4 from the equation y equals x. As you can see here, we are trying to find the volume that is revolved around the x-axis from 0 to 4 on the graph y-x, and to find the area, as you have learned, integrals 0 to 4 to find the area under the graph, and x. And to find the volume, you just have to use the equation of the circle and have pi, and r is replaced with the function squared dx, and dx is infinitely thin, and what dx is basically where all the circles are added all together infinitely thin from the interval 0 to 4. And since pi is a constant, you can take off the pi out and leave into this form. Okay, so to solve this, you basically just integrate this and you will get 64 over 3 pi as the volume of the graph, the volume that is generated when y equals x from intervals x equals 0 to x equals 4 is revolved around the x-axis. And you can see here the basic setup for the disk method is in this equation right here. Okay, so the disk method. So in this example, we are going to learn how to find the volume that is generated when the intervals x equals 0 to x equals 2 in the graph y equals x squared in the y-axis, so generated like this, and from the and generated in the x-axis, such as like this. And so we are going to learn how to do that in the next few slides. So first, as you can see here, this is the same form as we learned previously. You basically have to find the volume generated around the x-axis. Plug in pi, the interval, the sum of 0 to 2. Integral is also called the sum of. And plug in the equation x squared, and then don't forget the squared here because this is part of the equation of the circle. And plug in, put in dx because these are infinitely thin circles, and it is basically the height of the object. And to find the volume around the y-axis from the intervals x equals 0 to x equals 2 is not really that complicated either. Since it's asking you to find the volume around the y-axis, you should remember to get y equals x squared and get it y in terms of x instead, and so just follow this format here, and you'll get y to the power of 1/2, which is also square root of y, and plug it into the equation right here. And don't forget the squared, which is part of the equation of the circle, y equals pi r squared. And also don't forget that if you change the form of the equation from x in terms of y to y in terms of x, you should also change the intervals. So in this example, since in this terms of y, the interval should also be in terms of y values. So plug in x equals 0 and x equals 2 into y equals x squared to get y equals 0 and y equals 4 respectively. And so as you can see here, we are adding infinitely thin circles all together to find the volume that is revolved around the y-axis. And these, since we are revolving around the y-axis, it is important that the interval 0 to 4 is 0 to 4. And if you just remember this format of circles and you can use this method to find different kinds of volume problems. Okay, that's it for now.